At the end of the module, you should be able to 1. Define mineralogy and minerals, define crystallography and identify symmetry elements of crystallographic systems, and identify the physical properties of minerals.
So our topic is mineralogy. Mineralogy is a scientific field that studies the physical, chemical, crystallographic properties of minerals, their distribution and origins under physicochemical conditions. Minerals. Minerals are naturally occurring inorganic substances with uniform chemical composition, while rocks are collection of minerals. Understanding rocks' composition and properties requires understanding common minerals and identifying them. Minerals are naturally occurring homogeneous solid chemical substances formed through inorganic process with distinct chemical composition. Ordered atomic structure and specific physical properties. A mineral by definition cannot be liquid or gas. Chemical composition of mineral is infinite, meaning a particular mineral is always composed of the same ratio of elements. This composition can be shown using a chemical formula. The atoms in mineral are arranged in a highly ordered fashion called lattice structure. Crystallography. What is crystallography? Crystallography is the study of mineral specimens' regular pattern of faces and angles, indicating its internal structures and regularity of form when it goes outward into the solution of our milk. The specimen is crystalline, despite not being a crystal in an imperfect crystal. Some faces have developed more than others, maintaining the same angle as a perfect crystal. The study of the regularity of crystal forms, including the values of the facial angle, shows that all crystals possess certain elements symmetry which include center of symmetry, which a crystal possesses when in all its faces occur in parallel pairs and opposite sides of the crystal. A crystal symmetry which is aligned to a crystal such as the complete rotation of 360 degrees about to produce more than one identical view. Plane of symmetry which divides the crystal into halves, each of these is a mirror image of other without rotation.
Physical properties of minerals. Number 1 is color. In mineralogy, color is one of the primary diagnostic properties of natural compounds, of great importance in geological prospecting for the identification of minerals. Para po natin ma-identify yung minerals, ang step 1 po natin na ginagawa ay tignan natin yung kulay nito. The color is a constant and predictable component of the mineral. Meaning po, yung kulay po nito ay pare-parehas lang at kaya nating mahulaan or makita. And there are three main groups of minerals are identified on the basis of the property of color. These are idiochromatic, allochromatic, and pseudochromatic. Yung idiochromatic are called self-colored. The color is constant and predictable. Kumbaga, pare-parehas lang. Sa kanila lang talaga. And, kaya mo siyang i-predict o mahulaan. Yung pangalawa naman is allochromatic or called other color. Due to trace impurities in their composition or defects in their structure. In this case, the color is a variable and unpredictable. Sabi nga dito, defects in their structure. Dahil doon, nagkakaroon sila ng pabago-bagong kulay at hindi mo kayang hulaan or unpredictable nga sabi nga nila. And pseudochromatic. Minerals are called false colored due to tricks in light diffraction. In this case, color is variable or paiba-iba rin pero unique naman yung property of the mineral. Number 2 is streak. The streak is also called powder color of a mineral is the color of the powder produced when it is dragged across an unweathered surface. Unlike the apparent color of a mineral, which most minerals can vary considerably, the trail of finely ground powder generally has more consistent characteristic color. Meaning, ginagamit din po yung strike para madiskubre yung totoong kulay ng mineral. Halimbawa po, ito po yung bato. Tapos, ito po yung pagkakaskasan. Pagka kinaskas po natin ganun, yun po magkakaroon siya na parang kulay puti. Yung puti na po na yun yung tinatawag na powder color ng streak. Kaya po siya, isa rin siya sa magandang halimbawa para madiskubre kung maganda yung kulay ng minerals or kung ano yung kulay ng minerals, yung totoong kulay. Kasi nga po, di ba pwede siyang maging variable and unpredictable, paiba-iba. Number 3 is hardness. Hardness is measured by the resistance which a smooth surface offers to abrasion. The degree of hardness is determined by observing the comparative ease or difficulty which one minerals is scratched by another. And this is Mohs hardness scale, created in 1812 by German geologist and mineralogist Friedrich Mohs. So paano nga ba natin malalaman kung gaano katigas yung minerals? Sabi nga po dito kanina is one mineral is scratched by another. Halimbawa na lang po itong talc tsaka itong gypsum. Yung talc is may scale number na 1 and gypsum is may scale number na 2. Pagka in-scratch mo sa talc, yung talc is magkakaroon ng powdered. Doon mo malalaman na yung gypsum is mas matigas kaysa sa talc. Ayan po. Ibig sabihin po na to, yung talc ay may gypsum, calcite, fluorite, apatite, papataas po yung scale number nila. And yung diamond po yung may pinaka mataas na hardness scale o yung pinakamatigas po na bato. And ang number 4 naman is crystalline structure. Meron tayong individual crystals na tinatawag. And this is platy. Yung platy ay broad flat crystals. And yung meron pa tayong tabular. Tabular is elongate crystal which is also flat. Prismatic. Prismatic is elongate in one direction. Acicular. Acicular crystal is very long and needle-like. Fibrous. Long crystal like fibers. Crystal aggregates. Amorphous minerals often assume like this form. Dendritic. Crystals diverge from each other like branches. Reniform. Kidney shape. Yung botryoidal like a bunch of grapes. Amygdaloidal. It is like a infilling of steam vesicles or holes in lavas by salts carried in solution. And yung panghuli po ay Dracy, crystal found lining a cavity.
Let's talk about cleavage and fracture. Cleavage is the tendency of a crystal to break along smooth, flat planes of structural weakness. Parting is the separation of lamellae in a crystallized mineral not due to cleavage. Fracture is the tendency of a mineral to break along the curved surface with irregular shapes. So, the difference between cleavage and fracture is that yung cleavage kapag hinammered mo yung minerals and nag-break siya into two, and you see a smooth surface, that means the mineral have cleavage. But when you hammered a mineral and you got a rough and uneven surface, that means the mineral have fracture. Note that there are minerals that exhibit 1, 2, 3, or more cleavage planes, and there are minerals that exhibit none at all. And cleavage plane is always parallel to a crystal face. Now we have diaphanity or transparency. The diaphanity of a mineral describes the ability of light to pass through it. Ibig sabihin, when you look closer sa mineral, makikita mo yung nasa likod ng mineral o yung tinatawag na nating transparent. We have transparent minerals, which do not diminish the intensity of light passing through them. It means you can see right through it, as in clear yung vision na makikita mo. Next, we have translucent minerals that only allow some light to pass, but less than those that are transparent. See shapes and shadows through it when it is sliced thin. Chemical impurities can cause the minerals to be cloudy. Minerals that do not allow light to pass are called opaque. It means can't see light through it at all even if it is sliced thin. Now, we have tenacity.
This tenacity describes the reaction of a mineral to stress such as crushing, bending, breaking, or tearing. It is the resistance of minerals to certain forces. Minerals react differently to different types of stress. We have here the different forms of tenacity. Number 1 is brittle. If a mineral is hammered and the result is a powder or small crumbs, it is considered brittle. Brittle minerals leave a fine powder if scratched, which is the way to test a mineral to see if it is brittle. The majority of all minerals are brittle. Tumutukoy ito sa tibay ng minerals. Kapag ang mineral ay madaling madurog o ma-scratch, ibig sabihin nito madali lang siyang ma-shatter. Number 2 is sectile. Sectile minerals can be separated with a knife, much like wax but usually not as soft. Ito naman, tenacity ito na tumutukoy sa mga minerals na kayang i-separate gamit ang knife. As with the use of different equipment, kaya mo siyang hatiin smoothly. Number 3 is malleable. If a mineral can be flattened by pounding with a hammer, it is malleable. It is the ability to bend without breaking, even if you hammered it into thin sheets. Note that all true metals are malleable. We have number 4 is ductile. A mineral that can be stretched into a wire is ductile. All true metals are ductile, like gold, silver, like our accessories. We have number 5 is flexible but inelastic. Any mineral that can be bent but remains in the new position after it is bent is flexible but inelastic. So when we say elastic, it is the ability to go back to the original shape or form of something. So it means these minerals are flexible but not flexible enough to go back on its own shape. And lastly, we have flexible and elastic. When flexible and elastic minerals are bent, they spring back to their original positions. Now we have magnetism. Occurs most often when there is an imbalance in the structural arrangement of the iron ions. Normal magnetite is attracted to a magnet, but some specimens are automagnetized and have the ability to attract small pieces of iron, small pieces of magnetite, and other magnetic objects. Magnetic properties of minerals. We have ferromagnetism, describes strong attraction to magnetic field. It talks about minerals na can easily be attracted to magnets. While paramagnetism is weak attraction to magnetic fields, the attraction is usually discernible, but it may be so weak that it is undetectable. Most paramagnetic minerals become strongly magnetic when heated. We also have diamagnetism, means only one mineral. Bismuth is a diamagnetic, meaning it is repelled from magnetic fields. Instead of being attracted, it is being pushed away.
Luster. Luster describes how a mineral appears to reflect the light and how brilliant or dull the mineral is. Luster o pagkinang. Pinapakita ang pagkinang ng isang mineral kapag tinamaan ng ilaw o liwanag. The terms used to describe luster are: first, metallic. Minerals with a metallic luster are opaque and reflective like metal. Metallic. Yung mga kasama raw dito ay opaque o hindi tumatagos yung liwanag sa kanya at nababounce back niya yung liwanag o reflective. Mga sulfide or may element ng sulfur at ibang oxide ang kabilang rito. Second, submetallic. Sa submetallic, ito naman yung hindi tumatagos hanggang sa kaunting tumatagos yung liwanag at nakakapag-bounce ng liwanag ng maganda. Maliit na bahagi lang nito ay mapapasukan or maaaring daanan ng liwanag. Vitreous. 70% nito meron ang lahat ng mineral. Yung mga meron nito ay may kamukhang reflective property tulad ng silicon, carbon, phosphorus, sulfur, halogen with more electropositive element, and hydroxides. Hydrogen with one oxygen ay mayroong vitreous luster. Next is adamantine. Adamantine, transparent to translucent minerals with a high refractive index yield an adamantine luster, meaning they display extraordinary brilliance and shine. Next is resinous. This is the luster of many yellow, dark orange, or brown minerals with moderately high refractive indices honey-like, but not necessarily the same color. Next is silky. A silky luster is the result of a mineral having a fine fibrous structure. Minerals with a silky luster have optical properties similar to silk cloth. Next is pearly. Describe a luster similar to the inside of a mollusk shell or shirt button. Many micas have a pearly luster, and some minerals with a pearly luster have an iridescent hue. Some minerals may exhibit a pearly luster on cliff, crystal, surface parallel and below the reflecting surface of a mineral. Next is greasy. Luster of a mineral that appears as if it were coated with grease. Next is pitchy. Minerals with a tar-like appearance have a pitchy luster. Minerals with a pitchy luster are usually radioactive and have gone through the process of metamixtion. Next is waxy. A waxy luster describes a mineral that appears as if it were coated with a layer wax. And last but not the least, is dull. This luster defines minerals with a poor reflective qualities, much like unglazed porcelain. Most minerals with a dull luster have a raw or porous surface. Now, let's move to the odor. Several minerals give off distinctive odor in certain conditions, especially when the mineral is heated. Which means maraming mineral ang nagbibigay ng kakaibang amoy sa ilang particular na condition, lalo na kapag pinainit ang mineral. Next is taste. Taste is not the first or possibly even the last property someone would associate with minerals, and yet, taste is sometimes a very good characteristic and a key to identification in some cases. The most commonly tasted mineral is highlight or rock salt, but there are several other minerals that have a distinctive taste.
Specific gravity. The specific gravity of minerals determines how heavy the mineral is in relation to water, and it is expressed as the weight of the mineral multiplied by the equivalent volume of water. It is a measurement that determines the density of minerals. Two minerals may have the same size but differ in weight from one another. And there was osmium, the densest naturally occurring element on the earth, which is belong to the group of platinum metals, and it has a specific gravity of 22.6, and lithium is the least dense mineral on earth with a specific gravity of 0.554. Rock-forming minerals. These minerals are typically formed as an integral of rock-making process and form igneous, sedimentary, or metamorphic rocks. In contrast, other minerals have limited frequency of occurrence or formed by more common processes such as vein minerals or deposits and cavities. Engineering significance of rocks. It is important to know the property of rocks precisely to enable them to consider different rocks for any required purpose. All properties of rocks are in turn depends on the property of their constituent materials. Thus, the properties of civil engineering important such as their strength, durability, and appearance of rocks can be assessed only with the knowledge of minerals. Also, understanding the properties of rock is crucial for selecting suitable ones for various purposes. The key properties including strength, durability, appearance, and influence are by the characteristic of their constituent materials, primarily minerals in civil engineering assessment.